Hi guys, this is O-Level Chemistry, paper 11, June 2021, question 1. A student has to measure 28.2 cm cube of aqueous sodium bromide. Which piece of apparatus should the student select? Okay, first of all, they have given a value that is accurate to one decimal place. So in order to obtain accurate volumes, we need to use a burette. So first of all, burette would be the correct answer. But why would the other pieces of apparatus shown here be incorrect for this case? Let's look at them one by one. For A, it is just a beaker. A beaker is not used to measure volume at all. So it is just a container. It just has marking so that we know approximately what volume, nearing what volume do we have the solution present in the beaker. B, the burette. The burette is used to accurately measure variable volumes like 28.2, 28.3 because it has got gradations with a difference of 0.1 centimeter cube. C, a pipette. A pipette is also used to measure accurate volumes, but the volume that a pipette can measure is fixed based on the volume of the pipette itself. Like a 25 cm cube pipette can only measure a volume of 25 cm cube, nothing below or above that value. So a fixed value of 25 cm cube can accurately be taken using a pipette. The measuring cylinder. A measuring cylinder can be used to measure approximate volumes. Measuring cylinders are not very accurate in measurement. So if we need somewhere around 25 cm cube, like approximately 25 cm cube of a solution, then we can use the measuring cylinder. Usually measuring cylinders are used to take solutions that do not have a particular restriction for the amount taken. Like if it is said that HCl is in excess, so we need 25 cm cube of HCl. So this could be a little less or little more than 25 cm cube. So a measuring cylinder can be used for that. So we can say that a measuring cylinder can be used for measuring approximate volumes of a solution. So this makes option B the correct option for this question. Question 2. Which property of a liquid ester can be used to check its purity before use as a food flavoring? So, in order to check the purity of a substance, its melting and boiling points must be very much accurate. So, if the ester has any impurity in it, its melting or boiling point would be varied. But if it is pure, it would be exactly as the boiling point that has already been written in any textbook, or the boiling point that is already known, boiling and melting point. So the answer is boiling point. Now, why isn't the rest of the options the correct answer? The color of esters may vary, and even if you can add a color, the color can change, right? So a color is not an indication of the purity of a sample. Neither is the smell. Smell also can be changed by addition of something else, or in different quantities the smell can go up or down. Now, solubility in water. Solubility in water depends on the MR. The greater the MR, the less the solubility in water. So esters with a higher MR value would be less soluble, and esters with a lower MR value would be more soluble. So solubility is not an indication of purity. So we are left with boiling point as the correct answer. So option A is the correct option for this question. Question 3. Which sequence of procedures is used to separate a pure dry sample of hydrated copper 2 sulfate from a mixture containing hydrated copper 2 sulfate and calcium carbonate? So if we have copper 2 sulfate and calcium carbonate mixed together, copper 2 sulfate is soluble in water, calcium carbonate is not. So what we should do is we should first dissolve the contents in water. This would allow copper sulfate to change its state from solid to aqueous, whereas calcium carbonate will stay as a solid. Now, what we would do is we would filter this solution. So now the calcium carbonate will be obtained as the residue and copper sulfate as the filtrate. Now we have a solution of copper sulfate. Now in order to obtain pure dry sample of hydrated copper to sulfate, we use the process of crystallization. Crystallization will cause the water to evaporate and crystals to form in the container. So the process should be Dissolving our contents in water, then filtering, and then crystallization. So option A has dissolving in water, but then it has distillation. Distillation makes it wrong. Option B has dissolving in water, followed by filtration, followed by crystallization, which is correct. So option B is correct here. C starts off with distillation, it is wrong. D starts off with fractional distillation, which is also wrong. So this makes option B the correct option for this question. Question 4. J is an aqueous solution. On addition of an aqueous sodium hydroxide to J, a green precipitate is formed. The resulting mixture is heated and no gas is formed. Aluminum foil is added to the warm mixture. A gas is formed that turns damp red litmus paper blue. Okay. On addition of aqueous sodium hydroxide to J, a green precipitate is formed. This green precipitate means that Fe2 positive ions are present. The green colored precipitate is also for Cr3 positive ion, but in excess of sodium hydroxide, it would dissolve to give a green solution. So this is Fe2 plus ion. Now, next, the resulting mixture is heated and no gas is formed. So if sodium hydroxide is added and the mixture heated and no gas is formed, that means absence of ammonium ions is detected. So ammonium ions are not present in this sample. And aluminum foil is added to warm mixture. Now we have added sodium hydroxide, then we have warmed it, we have added aluminum powder, aluminum foil. A gas is formed that turns damp red litmus blue. This gas is ammonia, and ammonia is formed if our mixture contains nitrate or nitrite ions. NO3 minus is nitrate, NO2 minus is nitrite. So, which ions could be present in J? Fe3 plus, we did not get a red-brown color. Ammonia, we know, is no longer there. So, A, both the options are incorrect. B, Fe3 plus is wrong. Nitrate is correct. Fe in C, Fe2 plus is right. Ammonium is wrong. In D, Fe2 plus is correct and NO3 minus is also correct. So, this makes option D the correct option for this question. Question 5. Gas X has the following properties. It is colorless, so it is not chlorine gas because chlorine is a green colored gas. No effect on either damp red or blue litmus papers. So it is not an acidic or an alkaline gas. So it cannot be ammonia, it cannot be sulfur dioxide. Next, no effect on lime water. So this is not carbon dioxide and it is flammable. So let's look at the options. What is gas X? Ammonia. Option 2 eliminates the presence of ammonia. And next is chlorine. Option 1 eliminates the presence of chlorine. C is hydrogen. Hydrogen could be the answer. Let's look at D. D is oxygen. Now, the oxygen and hydrogen are both following steps 1, 2, and 3, or rather properties 1, 2, and 3. But hydrogen is a flammable gas and oxygen is not a flammable gas. So this makes hydrogen the correct answer. Thus, option C is the correct option for this question. Question 6. Which particle contains most electrons? So, oxygen has a proton number of 8 and a nucleon number of 16. So, it has 8 electrons and it has a charge of 3 minus. So, 8 plus 3 gives us 11 electrons in O3 minus. Now, next is neon. Neon has a proton number of 10, which means it has 10 electrons present. Next, Na positive, sodium has a proton number of 11, but it also has a negative charge here. So this would mean 11 plus 1, which will result in 12 electrons being present in this ion. And Mg3 positive. Mg3 positive has a 3 positive charge, that means loss of 3 electrons. It has a proton number of 12. So if we have 12 electrons present and 3 of them are lost, we are left with 9 electrons. The question asks us the most number of electrons, which is 12, making option C the correct option for this question. Question 7. The diagrams show the structures of two solids P and Q. Now, the structure of solid P is that of SiO2 or it is that of diamond. while the structure Q is that of graphite. Okay. Which row is correct? Has covalent bonding? P only? No, P and Q both have covalent bonding. So options A and B have been eliminated. Now the correct option is either C or D. Next, conducts electricity. P does not conduct electricity. Q conducts electricity because layers of graphite have a delocalized electron for each carbon atom present. So the correct option for this question is option D. Question 8. What is a covalent bond? A pair of electrons shared by two non-metallic atoms. Yes, sharing of electrons is what a covalent bond is. Electrons being shared by a lattice of positively charged ions. If the term positive ions is present and electrons are being shared, that means we are talking about a metallic bond here, not a covalent bond. C. Elements losing electrons to achieve a noble gas structure. Loss of electrons result in the formation of cation. So statement C is that for the formation of cations. D. Oppositely charged particles strongly attract each other. This happens in ionic bonds. Electrostatic forces of attraction exist between oppositely charged ions which hold each other very strongly. So this makes option A the correct option for this question. Question 9. The empirical formula of compound X is CH2 and the relative molecular mass of X is 70. What is the molecular formula of X? So we need to find the MR of 70 in each case. So CH2 has an MR of 12 plus 2, 14. In the case of B, we have C2H4. So 12 to the 24 plus 4 is 28. In the case of C, we have got C5H10. 5 12s are 60 plus 10 is 70. And in the case of D, we cannot calculate the MR here. So the correct answer for this question is option C. Question 10. A chemist wants to make calcium nitrate. They start with 8 grams of pure calcium oxide and an excess of dilute nitric acid. The, they produce 12.65 grams of pure dry anhydrous calcium nitrate crystals. What is the percentage yield of calcium nitrate? Now they've given us relative atomic masses and we need to find out the percentage. So first thing, what is the reaction between calcium oxide and nitric acid? It is CaO plus 2 moles of HNO3 giving us calcium nitrate and producing water. So if we look at the MR, calcium is 40 and oxygen is 16. So mass of 56 grams produces, now this is calcium nitrate. This would be 40 plus 14 into 2 plus 16 into 6. This will give us a value of 164 grams. So if we have 56 grams of calcium oxide, 164 grams of calcium nitrate is produced, and the question tells us that we are having 8 grams of calcium oxide. So how much of calcium nitrate would be produced? We would calculate 8 divided by 56 multiplied by 164. This will give us a value of 23.43 grams. Now, this 23.43 grams is the amount that is supposed to be produced. What we have here in the question is that 12.65 grams is produced and we need to find out the percentage yield. So for percentage yield, the amount produced as given in the question 12.65 divided by the amount that was supposed to be produced, which is 23.43 as calculated into 100 gives us a percentage yield of 53.99%, and this makes option A the correct option for this question.